January 1994, Dearborn, Michigan. Deep inside Ford's engineering offices, a diesel engine sat strapped to a dyno cell at full throttle. The sound was violent, raw, metallic. A deep hammering roar that shook the walls hard enough to rattle tools off shelves. Engineers watched oil pressure gauges, EGT readings, coolant temps, hour after hour, day after day. Because Ford wasn't just testing another truck engine, they were fighting for survival. At the time, Ford's heavy-duty truck division had a serious problem. Dodge had just unleashed the Cummins-powered Ram, and suddenly, truck buyers were obsessed with torque. Real torque. Not marketing numbers, not gas engine promises. They wanted diesel-pulling power. They wanted engines that could tow mountains and still come back for more. Ford needed an answer, and what happened next created one of the most respected engines in American history. The 7.3 Powerstroke, an engine so durable that people still drive them today with 500,000, 800,000, even over 1,000,000 miles on the original block. But most people have no idea why this engine became legendary. Because the real story isn't just about reliability. It's about over-engineering. It's about oil pressure, forged internals, brutal towing loads, and an engine architecture so tough, it bordered on industrial equipment. And the craziest part? Ford almost never built it. Back in the early 1990s, diesel trucks were changing fast. Before that, most heavy-duty pickups were slow, noisy workhorses. Farmers loved them. Construction crews needed them. But regular buyers? Not really. Diesel engines were known for smoke, clatter, and terrible acceleration. Then Cummins changed everything. The 5.9-liter 12-valve Cummins in the Dodge Ram made 160 horsepower and 400 pound-feet of torque in 1989. Those numbers sound small today, but back then, it felt unstoppable. Especially for towing. The inline-six layout was simple, brutally strong, and easy to modify. Truck buyers noticed immediately. More importantly, they started switching brands. Ford loyalists were walking into Dodge dealerships asking about Cummins power. That kind of brand defection terrified executives in Dearborn. Ford knew they were behind. At the time, Ford was using the old 7.3 IDI diesel built by International Harvester. IDI stood for indirect injection. It was dependable, but compared to the Cummins, it lacked efficiency and power. The naturally aspirated versions barely cracked 185 horsepower. Even the turbocharged version struggled under heavy loads. Throttle response felt glacial. Smoke poured from the exhaust under acceleration. And worst of all, customers were starting to complain publicly. Ford needed something modern, something faster, something that could survive abuse from ranchers, hotshot drivers, snowplow fleets, and contractors hauling 15,000-pound trailers through mountain grades every single day. So Ford partnered with Navistar International to develop a completely new engine platform. Internally, it was called the T444E. The partnership made sense. International had decades of experience building medium-duty diesel engines for commercial trucks. They understood durability in ways that most automotive engineers didn't. They knew what components failed under sustained abuse. They understood bearing loads, thermal cycling, and the kind of punishment that destroyed weaker designs. Ford gave it a different name, Powerstroke, and the engineering behind it was unlike anything most pickup buyers had ever seen. The heart of the 7.3 was a 4434 cubic inch V8 diesel. That's 7.3 liters. It used a cast iron block, cast iron heads, forged steel connecting rods in early models, and a deep skirt block design built to handle enormous cylinder pressure. Bore measured 4.11 inches. Stroke came in at 418 inches. Compression ratio? A massive 17.51. This thing was built like industrial machinery. The block casting alone weighed significantly more than comparable engines. Engineers designed the main bearing caps with 4-bolt configurations on critical journals. The crankshaft measured nearly 4 inches in diameter at certain points. Oil passages were drilled oversized to ensure maximum lubrication flow even under extreme heat and load conditions. But there was one feature that changed everything. HEUI injection. Hydraulically actuated electronically controlled unit injection. And yes, that name sounds complicated because it was. Instead of using a traditional mechanical injection pump like the Cummins, the 7.3 used high-pressure engine oil to fire the injectors. A high-pressure oil pump could generate over 3,000 psi, actuating injectors with incredible precision for the time. That allowed cleaner combustion, better throttle response, quieter operation, and more power. The system operated through a complex network of oil rails, pressure sensors, and electronically controlled solenoids. When the PCM commanded fuel delivery, high-pressure oil forced the injector plungers down, atomizing diesel fuel into the combustion chamber at pressures exceeding 21,000 psi, at least in theory. Because early testing was rough, really rough, engineers discovered the HEUI system was extremely sensitive to oil quality and pressure stability. Cold starts became a nightmare during winter testing in Minnesota. Injectors misfired. ICP sensors failed. Oil aeration caused erratic injection timing. Some prototype engines wouldn't start below 0 degrees Fahrenheit without extensive block heater use. Others developed strange hunting idle conditions when the high-pressure oil temperature dropped too low. One engineer reportedly joked, "The engine runs better angry than cold." But Ford kept pushing. They redesigned oil pump internings, upgraded sensor tolerances, modified injector O-rings, recalibrated fuel delivery maps across thousands of temperature and load conditions. Testing became obsessive. Every failure meant another week of diagnostics, another round of component revisions, another cycle of validation testing. And then the real torture testing began. They loaded Super Duty prototypes with massive trailers and sent them into Arizona heat. Temperatures climbed past 110 degrees. Exhaust gas temps soared beyond 1,200 degrees. Cooling systems screamed for mercy. Drivers ran uphill grades at full throttle for hours. Some test routes involved continuous climbs lasting 40 minutes or longer, all while pulling maximum rated trailer weights. Brake temperatures glowed cherry red during descents. Transmission fluid temperatures spiked into dangerous ranges. The goal wasn't comfort, it was destruction. Ford wanted to find the weak points before customers did. And they found plenty. Early turbocharger setups developed excessive shaft play under prolonged towing. Exhaust back pressure created heat soak issues around the up pipes. Oil leaks appeared near high-pressure lines. Some injectors failed under sustained heavy load because microscopic metal debris contaminated the oil system. Turbo pedestal O-rings degraded faster than expected under thermal cycling. Exhaust manifold studs stretched and broke. Intercooler boots separated under high boost pressure. But what engineers discovered next changed the future of the engine. The bottom end refused to die, even under horrifying abuse. The forged steel crankshaft survived punishment that destroyed surrounding components. Main bearings stayed intact. Cylinder walls held compression. Rods took astonishing cylinder pressure without bending. Even when turbos failed, injectors stuck open, or cooling systems overheated, the core internal components kept functioning. Tear-down inspections showed minimal wear on journals and bearing surfaces even after extreme testing cycles. That strength became the foundation of the legend. By the time the 7.3 Powerstroke officially launched in Ford trucks for the 1994.5 model year, it produced 210 horsepower and 425 pound-feet of torque. Those numbers don't sound huge now, but compared to earlier diesels, it felt revolutionary. The power delivery was smooth, progressive, and predictable. Turbo lag was minimal for the era, and the engine pulled hard from low RPMs all the way to redline. And buyers noticed immediately. Truck magazines praised the engine's towing performance and drivability. The electronically controlled injection made throttle response smoother than older diesels. Cold starts improved dramatically. And unlike many competitors, the 7.3 could handle hard work day after day without constant failures. Fleet managers started ordering them in bulk. Construction companies replaced entire truck lineups. Word spread fast through industries that depended on reliable equipment. But there was a problem. Ford owners started modifying them, and the engine handled it far better than anyone expected. See, diesel tuning culture exploded in the late 1990s. Performance chips, larger injectors, upgraded turbos. Owners wanted more power. A lot more power. And the 7.3 responded almost too well. Small companies started developing programmers that modified fuel delivery curves, injection timing, and boost pressure targets. Some were simple resistor modifications. Others used sophisticated handheld devices that rewrote PCM parameters. Stock automatic transmissions started exploding long before the engines did. A simple tuner could push some versions from 235 horsepower to over 300 horsepower with minimal hardware changes. Add larger injectors and a bigger turbo, and some trucks were making over 450 horsepower while still using unopened factory-long blocks. Transmission shops started seeing a flood of destroyed 4R100 automatics with burnt clutches, cracked torque converters, and twisted input shafts. That wasn't supposed to happen. The secret was cylinder pressure tolerance. The early forged connecting rods used in many 1994.5 to 2000 engines were unbelievably strong. Tuners discovered these engines could survive enormous boost pressure if EGTs stayed under control. Some owners pushed over 40 psi through stock bottom-end engines. Cylinder head studs became the common upgrade, not internal components. That fact alone spoke volumes about the underlying strength of the platform. And somehow they lived. Diesel mechanic Gale Banks once described the 7.3 as a platform with medium-duty DNA trapped inside a pickup truck. That's exactly what it felt like. And nowhere was that toughness proven more brutally than in towing. Across America, these trucks became workhorses for hotshot drivers, hauling equipment coast to coast. Fifth-wheel campers, horse trailers, excavators, construction equipment. Some trucks accumulated 50,000 miles a year under constant load. Drivers reported running continuous 12-hour shifts pulling heavy loads without overheating or mechanical failures. Oil change intervals became religious rituals. Fuel filter replacements happened like clockwork, because owners learned quickly that proper maintenance meant these engines would outlast the trucks they were bolted into. Most engines wear out quickly under that kind of punishment. The 7.3 almost seemed to enjoy it. Owners started reporting absurd mileage numbers: 400,000 miles, 600,000 miles, 800,000 miles on original internals. Some fleet trucks crossed 1 million miles with only injector replacements, turbo rebuilds, and routine maintenance. Online forums filled with odometer photos showing six-figure mileage on trucks that still ran perfectly. Stories circulated about ranch trucks with over 20 years of continuous service still hauling livestock trailers every single week. And maintenance mattered, because despite its legendary durability, the 7.3 had weaknesses, serious ones. Camshaft position sensors failed so often that many owners carried spare CPS sensors inside the glove box. If the sensor died, the truck shut off instantly. No warning, no restart. You'd be driving down the highway, and suddenly the engine would cut out completely. Experienced owners learned to recognize the subtle stumble that sometimes preceded total failure. Parts stores started stocking CPS sensors in bulk because demand was constant. High-pressure oil leaks caused hard starts. Injector O-rings degraded over time. Turbo pedestal seals leaked oil into the valley. Exhaust back pressure valves stuck closed in cold weather. ICP sensors developed internal failures that caused extended cranking before startup. IPR valves stuck open, dumping high-pressure oil back into the reservoir. UVCH connectors corroded in humid climates, causing individual cylinder misfires. And then there was the transmission disaster. The 4R100 automatic transmission behind many 7.3 trucks struggled badly under modified power levels. Add a tuner and heavy trailer, and torque converters overheated fast. Clutches burned, input shafts twisted. Transmission builders made fortunes installing upgraded clutch packs, billet input shafts, and modified valve bodies. Some owners swapped in manual transmissions just to avoid the automatic transmission nightmare entirely. One transmission builder famously said, "The engine was ready for war. The transmission brought a butter knife." But even with those flaws, the engine's reputation kept growing because competitors were starting to stumble. The late 1990s and early 2000s became a dangerous era for diesel manufacturers. Emissions regulations tightened. More electronics appeared. Exhaust gas recirculation systems complicated engine design. Reliability suffered industry-wide. GM's Duramax had injector issues. Dodge Cummins trucks dealt with lift pump failures and automatic transmission disasters. Every manufacturer struggled to balance power, emissions, and durability. And that's where the 7.3 earned its mythical status. Compared to what came next, it looked almost indestructible. Ford replaced the 7.3 with the 6.0 Powerstroke in 2003. On paper, the 6.0 looked superior. More power, better emissions compliance, faster spool-up, variable geometry turbocharging. It produced up to 325 horsepower and 560 pound-feet of torque. Marketing materials promised revolutionary performance and efficiency. But reality was brutal. EGR failures, head gasket problems, oil cooler issues, stiction failures, FICM breakdowns, head bolts stretched under cylinder pressure, EGR coolers cracked and dumped coolant into the intake, oil coolers clogged and caused catastrophic oil starvation. The problems appeared quickly and spread fast. Owners experienced repeated failures even under warranty. Some trucks spent more time at dealerships than on job sites. Suddenly, owners looked back at the old 7.3 like it was sacred machinery. Truck values skyrocketed. People started hunting clean 7.3 trucks specifically because they trusted them more than newer diesels. Some owners refused to sell them at any price. Others rebuilt entire trucks around tired 7.3 drivetrains because replacing the engine felt cheaper than gambling on modern emission systems. Low-mileage examples commanded premium prices. Clean, single-owner trucks with maintenance records became highly sought-after collectibles, and the numbers behind the legend are still staggering. From 1994 to 2003, Ford and International built roughly 2 million 7.3 Powerstroke engines. That's an enormous production run for a diesel platform. Yet decades later, thousands remain on the road working every single day. You still see them pulling trailers at construction sites, hauling campers through national parks, plowing snow in northern states, running ranch errands in Texas and Montana. Some tuners have pushed fully built 7.3s beyond 700 horsepower. Drag racing versions have run quarter-mile times in the low 11-second range at over 120 miles per hour. Not bad for an engine architecture designed primarily for towing livestock and construction trailers. Dedicated racing blocks with forged pistons, upgraded rods, and compound turbo systems have proven the platform's capability far beyond original factory intentions. But the real magic wasn't horsepower. It was trust. People trusted these engines deep in the mountains, in oil fields, on cross-country hauls, during snowstorms, during hurricanes. They trusted them because the engines earned it mile after mile after mile. There's something powerful about driving a truck into remote areas, knowing the engine won't leave you stranded. That confidence became part of the 7.3 ownership experience. And maybe the most impressive part of all? The engineering philosophy behind the 7.3 feels almost impossible today. Modern diesel trucks are technological monsters. They make over 1,000 pound-feet of torque straight from the factory. Some produce more than 500 horsepower stock. They're faster, cleaner, quieter, and vastly more advanced. They have advanced emission systems with diesel particulate filters, selective catalytic reduction, and multiple sensors monitoring every aspect of combustion. But they're also unbelievably complex. The 7.3 came from a different era. An era when engineers still overbuilt components because failure in a work truck could destroy someone's livelihood. So they used thick castings, massive bearing surfaces, conservative tuning, huge safety margins. They designed for worst-case scenarios and abuse patterns that most engines would never see. That's why these engines survive abuse that kills newer designs. And yet, even legends fade. By the early 2000s, emissions laws tightened dramatically. Nitrogen oxide standards became harder to meet. The old HEUI system struggled to keep up with modern emissions requirements. Noise regulations grew stricter. Fuel economy expectations increased. The engine architecture that made the 7.3 so durable also made it difficult to modify for new regulations. The 7.3 simply couldn't evolve forever. Production ended in 2003. And when it disappeared, an entire era of diesel engineering disappeared with it. Today, clean, low-mileage 7.3 trucks have become collector vehicles. Some pristine examples sell for shocking prices. Enthusiasts obsess over forged rod early models, 6-speed manual versions, and rare limited trims. Entire companies now specialize in restoring and upgrading old 7.3 Super Duties because demand never died. You can buy complete rebuilt engines, upgraded turbos, performance injectors, and every single replacement part needed to keep these trucks running forever. Replicas of modern reliability couldn't replace the feeling these trucks created. Because the legend wasn't built in advertisements. It was built on job sites, on highways, in freezing winters, pulling impossible loads with the odometer spinning endlessly forward. It was built by the rancher who drove his 7.3 for 15 years without major repairs, by the contractor whose truck hit 700,000 miles still on the original engine, by the families who crossed the country towing campers without a single breakdown. That's why people still talk about the 7.3 Powerstroke like it's some kind of mechanical folk hero. Because in many ways, it is. It wasn't the fastest diesel ever built. It wasn't the cleanest, or the quietest, or the most advanced, but it became legendary for something far more important. It refused to quit. That forged crankshaft, those thick cylinder walls, that brutal HEUI injection system, and a bottom end built like industrial equipment created an engine that outlived entire trucks around it. A million-mile legend born from over-engineering and relentless punishment. An engine that proved durability isn't about fancy technology or impressive spec sheets. It's about fundamental engineering integrity and the willingness to overbuild components even when accountants say it costs too much. And honestly, in today's world of disposable machines, that kind of durability almost feels unbelievable. If you enjoyed this story, let me know what engine or automotive legend you want to see next. Another diesel rivalry, a forgotten racing monster, or one of the greatest engineering disasters ever built. And make sure to subscribe so you don't miss the next deep dive into the machines that changed automotive history forever.